helping you with Acorn and RISC-OS computing.
Thank you very much. Right, let me just press screen share and we can share. Some slides. Let's just miniaturize all the Zoom windows out of the way. There we go. Right, okay. That's what we wanted to see. So yes, okay. What I'm hoping to show today is going to go. There we go. Is basically two topics. I thought it might be interesting to take a look behind the scenes. I appreciate that I've chosen probably the nichiest of the nichiest of things that LSR has designed recently, which is an Ethernet interface. Don't focus too much on that. It's the general process that I'm trying to show. The fact that it's an Ethernet interface, probably not that relevant. The same steps are involved regardless of what you're making. And then a quick look at CloudFS, or a reminder of CloudFS, which I found out was released in 2017, which seems oddly long time ago now. So I thought it'd be worth a quick recap on that. And then just to tempt fate, putting those two things together, I'm going to attempt to send some data through a distance of 1,055,002.6 meters of wet string, and the 2.6 meters of string is in here in the room beside me, which was what I was getting a table out for earlier when to set up a system which is just by my knees. So firstly, let's look at the design of a NIC, taking it as an example. Got a little video because then I don't have to hold things up to the camera, which will invariably be out of focus. So this is an Ethernet NIC, nothing too exciting about it. It's mainly a single-sided design, 4-layer PCB, and a pile of chips. Much like most of the things that I do, it's a rectangle, a green rectangle with some chips stuck on it. Pretty much everything I ever do falls into that general category. So how does all this come about? What's the sequence of events that goes behind designing something new? Well, firstly, it's coming up with the idea, and I'm great at coming up with ideas that are of interest only to me. I keep thinking of designing a washing machine, and I realize that actually the parameters that I would want for a washing machine are probably to have a serial port on the front so that I can control it with a computer. And if you were to try and make that and sell it in curries, nobody would be interested in it because I'm the only person that wants a washing machine with a serial port on it. So actually, it's important to go and ask people what it is that they're having trouble doing, or what they would like to be able to do, and trying to make those things easier to do. Another strategy that I've had is to simply look at an existing product and then work your way around each of the expansion ports until you've made one thing for each expansion port. That's another good tactic. And also quite a bit of the work that I do is not specifically in RISC-OS related stuff. So often you will see, oh, I see, that's how that works in some other totally tangential market, and to try and copy that and translate, how would you do that in RISC-OS? And I guess CloudFS is an example of that. Didn't previously exist a cloud filing system. I saw people using it frequently to transfer files from their phone to Dropbox, for example. I thought, oh, okay, we need an equivalent of that. So that's generally the sequence of events that comes up with an idea. Now, there's a big difference, as I was saying, with my washing machine with a serial port on it. There's a big difference between coming up with an idea and coming up with an idea that somebody else wants to buy. And that's a much more difficult question to answer, especially being into technology. It's really easy to over-focus on the technology side of things and forget about the selling part of things. And RISC-OS is quite an interesting market to be thinking about, because what these curves are showing, or these lines on this graph are trying to illustrate, is that if you sell an awful lot of something, but you only sell it for £1, you still make a lot of money. So if you sell, for example, a Flappy Birds or the Angry Birds game for a mobile phone, yes, okay, you're only selling it for 99p, but you're selling 20 or 30 million copies. So actually, it's 20 or 30 million pounds is your development budget for that game. The opposite end of the scale, if you think you're going to sell 100 of something, then ultimately that sets the upper limit on your development budget, and therefore the scale of, or the ambition of the product. So having worked out where you are on those curves of how much can I spend developing it versus how many do I think I will sell, bearing in mind, LSR is not a charity, and the accountant does get very upset if I don't send in positive numbers at the end of the year. Hopefully the idea still makes sense. So not all of them do. So I'm as I say, I'm very good at coming up with ideas of things which are totally commercially impractical, but a few of them make it through that funnel that are both a good idea and something that I think I can sell. So then we move on to the interesting bit. As somebody who's interested in technology, it's doing the design. So in the case of the NIC, fortunately, a reasonable amount of the design is copy pastable from the Econet design guide. Acorn gave you the schematic for the transmit and receive circuitry, because it was exactly the same transmit and receive circuitry that the BBC Micro used. So that bit didn't require too much head scratching, but obviously there's the rest of the paraphernalia around it to make it interface with the module bus inside the RISC PC. I haven't shown on this bit of schematic, but yeah, this bit of the schematic is just copy pasted from Acorn's original design. So once you've got the schematic is, the purpose of that is to capture a net list. So you want to know the relationship between all of the components and what other component do they get routed to. So that in computer aided design terminology gives you the net list. The net list then gives you big pile of components sitting in a board outline. So I've drawn the board outline for the PCB on the left, and then you've got a load of components from the schematic that all need wiring up. Now, a few of the things are defined in documentation as being in certain places. So I have to put the connector in the middle, because otherwise it doesn't come out of the hole at the back of the case. That would be a disappointment. And the position of the module bus connector, or the expansion bus connector, is obviously fixed as well, because it needs to mate with the corresponding place on the motherboard. So those two things I didn't have any choice on. They have to go there. The rest of them, I have pretty much free reign over where they get sprinkled around in the design. Fortunately, because I was trying to cram it into a single-sided placement, I spotted that the EPROM chip, where this big through-hole component here, actually there was nothing going on underneath that component, so I was able to hide some address decode logic underneath that to save myself a bit of space. But yeah, basically placing all the components, making sure that it will all fit, leaving enough gap around the outside for some tracks. Always have to remember to leave space for the tracks. It's very tempting to cram all the components into the smallest possible space, and then you forget that you need to leave space for drill holes and for vias and things. And then once you've got the tracks done, so all of the nets from the net list have been routed, you can flood fill the rest of the space with copper. So this is the half of the design that's all done on computer-aided design, and the output from this is a set of Gerber files normally that you would send off to the board house. So a week or two later comes back from the board house a corresponding PCB that matches obviously the design that you sent them. Normally I would go for a first prototype to hand populate the first couple. It's not really worth setting up a production run just to make a couple of them. There's almost certainly going to be some kind of mistake. I don't think I've ever made a circuit board that has been right first time lucky. I think I'm right in saying that. I always make at least one stupid mistake. So generally, it's best to sort of write off the first one as being suitable for debug and early bring up. So on the back of the board, you might have noticed that there were some test points when I was showing the video earlier on there. Test points can be your salvation, so they cost you nothing. They're just little copper circles. But often if you make a mistake, they're useful for strapping wires to, because obviously if it's a 4-layer PCB, if you've made a mistake on one of the inner layers, you can't do anything about that because that's sandwiched between fiberglass. So putting some test points on the back, very handy. If you've made a mistake, you can cut a track and then wire it back using the test points. And then depending on what the nature of the project is, there may also be some software to debug. So those test points again come in handy for being able to probe on the back of things. There we go. I'm trying to remember whether I'd put a photo of that in. Yes, so you can see these little gold dots that don't apparently go anywhere. These are test points of nets that when I was doing the schematic design, I thought, yeah, am I totally sure I know where that one goes? So I put in a few test points so that if I made a mistake, I can cut and strap those back into place. So once you've got something to the point where the software, if there is software involved, that works, you at least have exercised each of the inputs and outputs. You're able to go and then try and get that to pass through compliance. So previously that would have been CE compliant. So when we were in Europe, it's UKCA, the UK Certification Authority, which suspiciously all of their standards are exactly aligned with the old CE standards. So fortunately, from a testing point of view, not much has changed in that regard. And most IT equipment you can get away with self-certifying. So that's different to something where you have to declare it to a notified body. So if I was making a good example I saw of a short video on the internet the other day was for the petrol pump at the filling station. So that is a thing for which that's covered by the Measurement Instruments Directive, and that is a thing that you have to notify people. So if you were the company that designed the pump that goes inside a petrol pump, you have to show that you are making the pump to a certain standard, and you have to submit samples every few months to the notified body to be able to continue making that. IT equipment is a lot more lax. IT equipment mostly self-certified, except for the case where there's an intentional radiator. Now, I don't mean the intentional radiator, the type that's keeping my feet nice and warm at the moment. It's the intentional radiator in the radio sense. So if you're deliberately transmitting something, so if it's like a Wi-Fi interface or a GSM modem, you are deliberately transmitting radio waves at a known frequency, and they're a lot more picky about that. So there's something called the Radio Equipment Directive, RED. I'm not sure whether they come up with the acronyms first and then try and work out something that would describe that, or whether they think of the description, it happens to spell a word. But yeah, RED is the Radio Equipment Directive, and that's what you have to submit to if you are the designer of a radio. But when you come to integrate that with some IT equipment, generally you can do that with self-certification as well. So yeah, anyway, so you go and do some EMC testing. EMC testing is to check that you're not interfering with somebody else and they are not interfering with you. So let me think which round it. Yeah, so for me interfering with someone else's equipment, that's checking that my emissions aren't too high. And similarly, the reverse is if people are transmitting radio waves, you don't want it to interfere with my equipment. And you can often hear, less so now, I think, now that the mobile phones are at much higher band. You used to get a clicking sound just before a mobile phone received a text message, and if you were next to a speaker or if you were next to a conference phone or something like that, and that was exactly the problem I'm just describing is that someone else's radio transmitter was too high power, and it was interfering with the speaker, and so you would hear this click 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 just before your text message arrived. So yeah, usually the hardest ones to pass are radiated emissions and immunity. There are also a pile of other tests that you should submit to for static discharge. So if you're rubbing your feet on some nylon carpet and accidentally touch on something, that shouldn't cause it to reboot or format the C drive on your computer or anything like that. And there's a bunch of extra testing if you're into designing power supplies, because they get plugged into the UK mains network, and UK mains can be a bit wobbly, so it'll go up and down in voltage. So you get sags and swells, particularly if you live like on a farm at the end of a really long cable. You'll get sags and swells during the day, so it won't be a nice uniform 240 volts. And you also get surges. If there's a nearby lightning strike, you can get several thousand volts briefly shoved into your power supply, so you need to be robust against that. And then the other bit of testing, environmental testing. So there's an awful lot of stuff that works fine at room temperature, but doesn't work fine at -40°C. Electronics tends to go a bit fooey at low temperatures, because the resistances go up, and so the signals slow down, and all kinds of strange things happen at when you freeze electronics. So assuming that you've managed to wriggle through some through your compliance testing, now is the time to do the second attempt. So as I say, I usually assume that the first PCB is a scrapper. It's a write-off. You'll never go into production with that. So you go back and make any corrections to the electronics, so that those are the things that are easy to see on the schematic. So you've fitted a diode back to front or something like that. Any mechanical clashes. So if you've built the sample and find that actually the connector wasn't in the middle of the back plate, and therefore it doesn't line up with the case, maybe you need to tweak something left or right a bit there. Personally, and this is probably just because I'm not a mechanical designer, I find that easier, as I say, just to build it and see what happens rather than modeling it. You can get, so in the same way that you get electronics CAD, electronics computer aided design, you can get MCAD as well for mechanical computer aided design, and you can model entire circuit boards if you want, even down to representations of resistors and things, and spend a great deal of time putting a model together to be able to see whether it will fit in the final application. But yeah, generally I find that modeling aspect takes longer than just building one and seeing. So that's generally my approach, is just build one and correct it in the second edition. Then you can fix up any compliance issues, and sometimes there's also an opportunity to simplify things from a manufacturing point of view. Just because something is solderable by hand doesn't mean that if you then go and make 500 of them, the people at the factory might not be able to do that on a machine if they can't get in quite as fine a place as you can when you're making something by hand. And there was an example of that. I'm just looking where it was. Yeah. So a couple of mistakes that I discovered which weren't apparent until I got the board back, is I had put the text Ethernet NIC, I'd put that in the wrong place on the board, which then meant when you fitted the metal back plate, you couldn't read the writing anymore. And that was the sort of thing that, yes, I could have spent ages mechanically modeling that, and I would have spotted that before I'd made one. But actually, just make one and see. It's immediately obvious as soon as you built one that you can't see the text. So I had to move that. And then, that was the manufacturability issue in the prototype. Those two capacitors that I've circled there were pointing the other way around, and that was fine for me making them with a soldering iron, because I can put my little 2mm tip and fit the soldering iron in there, but that was not in any way manufacturable. So I just rotated those round so that they can be placed automatically, which made things a lot simpler. And then since I've up issued it, I bumped bump the version number so that if I ever pick one out of a box in 5 years' time, I can figure out which one was which. So each new revision of the hardware, you bump the version number. Right, onto, yeah, I said I'm not a mechanical engineer, but invariably things do involve some mechanical design, disappointingly. So there's always some nuts and bolts involved, and I always come and forget these and come to them last. So fortunately, in the case of a nick, and this isn't always the case, obviously, in the case of the nick, Acorn defined what shape the little metal back plates needed to be, because obviously that needs to fit into the corresponding metal gasket in the back of the RISC-VC's case, depending on whether you've taken your RISC-VC to pieces recently. And yes, disappointingly, that turns out is not a standard part. It's nothing. It's not a standard width. It's not a standard length. It's not a standard height. So I had to go and find someone who would make me a folding die to fold the sheet round. So it is standard, standard thickness stainless steel. But the width, the length, and the height is not a standard of any sort. So I had to get that custom folded. The holes, because it's just small quantities, I'm realistic here that there's not a worldwide market of several million for these Ethernet interfaces, and in small quantities you can get stainless steel laser cut, so you can pretty much fab any shape that you fancy, including curves. So this was my design for the back plate. So the 18mm height part, where's my mouse pointer gone? There we go. 18mm height there, and the width were determined by Acorn because it needs to fit the space in the back of the computer. And the connector obviously needs lasering out, and because it's being done by laser, I can make that pretty much any shape that I want. So I went for a slightly curved D shape, and these funky little things here are part number, as you can see on the drawing, SMPS M2.5, exciting part numbers, ROS, are clinch nuts, which is a term I didn't know until I was making this. So those are fancy little, they're not spot welded in, which is what I thought they would probably have been done. They are nuts that have a little C clip in them, and then you squeeze them under high pressure into the stainless steel, and it briefly deforms the stainless steel and forms a really tight fit. So you end up with, effectively, a floating nut inside on the back of the stainless steel, and that's what the screws go into for the to hold the nick in place. So again, so I don't have to hold it up to the screen. This was the bag of back plates when they came back from the factory. I was a bit nervous because it was the first bit of stainless steel design I've done, but amazingly it was 18mm, which was a relief, because either that or I was going to have a lot of back plates that didn't quite fit, and those are the little funky nuts, the clinch nuts. So I was quite pleased with that, as someone who does not profess to be a mechanical designer particularly. So now we've got to the point where we've got a working circuit board design that passes compliance, and we've got some mechanical bits to go around it. You can work backwards from when it needs to be released. So if this is being driven by a show date, for example, I know that if the show is on the 20th of April, I can work backwards from that in order to start buying components. Yeah, typically in small run PCBs will take 2 to 4 weeks. The bit of slop there is because sometimes the courier is delayed, or they get stuck in customs, or something goes wrong, or you get bumped by another person at the factory by another customer who wants their boards more urgently and therefore pays more money for them. You fall off the roster. So 2 to 4 weeks is a good estimate. So basically, if you're thinking of a show at the end of April, you needed to have ordered them sometime mid mid-March in order to hit that date and to be sure that you're not just going to turn up with a load of empty boxes. Printing manuals and printing warranty cards and things is a lot quicker. They can be done in a couple of days plus courier transit time. And the other aspect of procurement, particularly with weird things like Ethernet NICs, which are going to potentially have quite a long lifespan, so several years of availability, but that use unusual or hard to obtain components, it's often easier just to buy a big box of the hard to obtain components and stick them in the cupboard. It's a very low tech solution. If you were to think, for example, that if there's a chip, I'm going to make one up here that costs 50p, and you buy 500 of them, then that's a £250 worth of chips you're holding in stock. And you can be pretty sure 500 is going to last you an awful long time, or it can possibly going to last you forever. Whereas having to go through a design respin where you're changing the circuit board, making another set of prototypes, going to the test house to do compliance testing, coming back and respinning it, making more of those, that's going to cost you certainly the test house is usually a few £1,000s. So overall, it's often cheaper just to take a view of how many you're going to need and stockpile any weird chips, because it's cheaper than respinning the PCB as a general rule. So now we've got all of our bits and bobs, and the courier has hopefully not dropped the box or left it and run away on the doorstep, that we've got enough bits to put together a full bill of materials. So there's a bill of materials that I think of, again, because I'm an electronics engineer, is there's the components that are stuck to the green rectangle. So there's a bill of materials for the electronics, and that's really simple to think about. It is the components stuck to the green PCB, but actually there's a whole product BOM behind that. And I did a quick look, and there is a product BOM for this Ethernet NIC, and I had a look at how many things were on that and reminding myself what they all were. So yes, there's a warranty card that comes in the box. You need to design a sticker to go on the EPROM that's got the software in it. The backplate we've just looked at. There's a couple of UNC /4 nuts. I think that's the right designation. The type of nut that you use on serial ports is weirdly not metric. So I can't remember what UNC is short for, but they're special nuts required for serial ports. And you need some fixing screws to hold the NIC into the RISC PC, and then you need a little bag to put screws into, and you need a pouch to put the address label in when you're sending it through the post or dispatching them. You need an anti-static bag to put the electronics in, and then you need a stock unit label to close the anti-static bag, and a serial lead for the Ethernet as it happens. And actually, yes, of course, you need the cardboard box itself. So it's very unglamorous, but it is important to remember to order the box that this thing goes in. So actually, simple though it might be, you end up with 20 items on the bill of materials that are not electronic components. So putting all the bits and bobs together in the box is quite ends up being quite involved. And so, in true YouTube fashion, we will do a quick unboxing. So there is the box. I did remember to order the boxes in this instance. So yeah, inside the box you've got there's the sticker and the anti-static bag. There's some screws, the drop lead, and the drop lead itself is made of several components. As you can see, there's a green shell and a cable. Then you need the instruction card, how to fit it. You need to remember to send that to the printer. So yeah, it's surprising for something as simple as that, how many bits there are. So, and we can shove the NIC into the hole. That's why we needed to get the 18mm back plate the right size, because otherwise it doesn't fit. And then it just attaches in the back a couple of M2.5 bolts. And there we go. We have fitted a nick. Easy as that. So now we've got a product and we've got it in a box. It needs some marketing, and that's something that's almost a swear word in the Acorn world, of remembering to market it to people once you've made it. In the UK, the shows are probably one of the best places to disseminate new products, or to launch new products at, because people have made the investment to go to the show. So they're avoiding paying the postage for a start, but they're also getting to see the item in person. For overseas, obviously that would be there's a lot of expense traveling to the UK to visit a show, so most of them go over the internet for overseas sales, and therefore you need a website, and the website needs to have a product shot, as you can see in the right there. Photo of what the thing it is that you're buying, and then enough of a description to explain what it is that they're buying. Also remembering to weigh the item, because obviously you need to post it at some point, and the weights go in bands. The sweet spot is less than 100 grams, so then that's the cheapest postage, but something like a nick is a few hundred grams, so unfortunately that one doesn't go in the cheapest possible band. And for overseas, you also need to dig out what the HTS, the harmonized tariff schedule, I think that's what HTS is short for, the harmonized tariff code, so that you can get through customs at the other end. I thought it'd be interesting to zoom in on the little picture, the little thumbnail that's on the LSR product page, because actually there's a whole extra bunch of work that goes behind that. It's been quite dull of late, so it's all very low tech. You just need a really bright light and a macro camera. And remembering, if anyone who's seen how TV sets work, you only need to build the set up to the edge of the field of view of the camera. So very unglamorous taking product photos, doing them in my tatty old trousers. On this one was me recording these bits of clips at the weekend, just downstairs on the living room floor, very low tech. So you end up generally with a photo of the product on a bland background, which you can cut out the products in the middle, and this is done in RISC-OS Paint, so it's all very, very low tech. So you just use the triangle drawing tool to fill in the section in the middle where the product is in some uniform color. Doesn't really matter what. I've chosen yellow here just for illustration purposes. That then allows you to cut out and make a hole where the product would have been, which then allows you to change the contrast of the surroundings. So you can make that much brighter white and grayscale it and give it a really nice blended shadow around the outside. And then if you use the opposite cutter tool, you can stamp out the bit that is the product only in the middle. So in other words, you create so I did this in Image Master, David Pilling's scanning software. If you contrast stretch this grey background here, you can then make essentially a cookie cutter, which is the opposite of the hole that you want to make. So you end up with one color image, which you can brighten and contrast stretch if you want for the main product, and then you end up with a border, which is usually you make that grayscale that has a nice blended off to infinity background, and then stitch them together, and that gives you a product image on the website. But you can do it all on RISC-OS. So RISC-OS Paint for cutting out the main bit in the middle, and then David Pilling's scanning software to do the compositing. Then once you've got something ready to release, sending off the fact that you have done something to all of the various news outlets. So there's a nice article here from RISCository from September last year with the Econet NIC being released. I sent the same text to Archive magazine, and that got sneaked into the news desk that month. So yeah, again, remembering to shout about it. If you don't tell people it exists, then nobody knows it exists. And then if I'm going to a show, I will often also produce like A4 glossy printout versions, basically print out a version of what's on the website essentially, so that people can take that away and look at offline. It's a nice thing. It's sort of an aid memoir. So even though maybe they're not buying it that day, they've got a thing in their hand to remember what it was that they were looking at, which is always worth doing. And that, I think, were all the steps involved in making an Econet NIC. So again, don't focus too much on the fact that it was Econet. That's very much a niche within a niche. The main thing to focus on was the general steps involved of coming up with the idea, looking at the business case, designing it, getting it through compliance, second iteration, and then boxing it up and marketing it. Okay. Swiftly moving on. So that was a hardware-y thing. This is CloudFS, much more a software-y thing. So I will quickly do a recap of that. Don't worry, there's only a couple of slides here. We've gone past the halfway mark here. So CloudFS is a cloud filing system, and for anyone who's not aware of that terminology, cloud is basically a server that exists on the internet which is not yours. So you're renting time on a server that you don't own. And a lot of websites now are actually hosted on cloud servers. So AWS, Amazon Web Services, are probably serving a lot of the websites that you visit on a daily basis, and there's no reason why someone couldn't buy a server and put it in their server cabinet and run it themselves. But actually sharing a server with someone else helps you divide the cost, and they also generally will deal with doing operating system upgrades, hardware upgrades. If a hard disk fails, someone while I'm asleep will go and replace that hard disk for me, and probably not even bother telling me that the old one had broken. So, but anyway, so that generally cloud services are a server that you are part-time renting some time on, but you don't own yourself. And obviously storage, you already know from saving things on your hard disk. So put them together. Cloud storage is basically like a remote hard disk that is shared on a server that you don't own. So generally you will rent it. There are some cloud storage providers that will charge you a monthly fee, or if you have an Apple subscription, they'll give you some space on their server, that sort of thing. So there's different business models depending on who's running the service. And generally, way to think of this now is storage is very cheap. Storage is a few pennies per gigabyte per month. Generally, it's come down a great deal since you would buy a Winchester drive that cost several £1,000s and had about 10 megabytes of storage. Yeah, storage is pretty cheap. So yeah, cloud storage is essentially being able to access your data regardless of where you are. So if you're out and about and you take a picture of a mobile phone, you can sync that with your cloud storage provider, and then when you're at home using a desktop computer or a tablet or something like that, you'll see that your files appear to already be there, and they've been synced behind your back while you were traveling between the two locations. The important thing to remember about cloud storage is that the principle of locality applies, which is a very fancy computing term, which basically means the closer the storage is to you, the faster it will be. So on the left here, that's not very good photo of a cache on a processor. So a processor cache now will be of the order of tens of gigabytes per second, super fast, because the processor is directly connected to, in fact, it's probably on the same piece of silicon as the cache. So you can get tens of gigabytes per second on that interface. The memory on your motherboard, which is a SIM or soldered down memory that's not on the main processor chip, will generally be gigabytes per second now. A hard disk will be hundreds of megabytes per second typically, and the internet will be megabytes per second. So basically for each step left to right on that drawing, there's like a factor of 10 at each stage. And I was thinking back, sort of casting my mind back 20 years or so, and I think that same sort of cascade of speeds applied even maybe 20 years ago. So if you imagine a 200 megahertz strong arm processor, that will have been of the order of a gigabyte per second to the cache, and maybe a few hundreds of megabytes per second to the motherboard RAM. And I think those numbers still stack up, and maybe tens of megabytes per second to the hard disk. And then we were probably on dial-up, so hundreds of kilobytes per second for dial-up. So I think even though technology has marched forward, I think those ratios have still those ratios all still hold true. So back here, grounding in RISC-OS. So there are, yeah, as I said a moment ago, if you have an Apple account, you've probably been given some iCloud, Apple iCloud storage. There are lots of cloud storage providers out there, all wanting to rent you space on their server. Amazon do a service for like a business-to-business service. I don't think you can join the Amazon cloud as a private individual anymore. I think it's a business-to-business interface. It's Google Drive. Microsoft will throw you a few terabytes of storage if you have an Office 365 account. And then the couple that I've highlighted in green there, it's pCloud and Dropbox. So I'm aware that there is a Dropbox client written in Python, which you can use to access Dropbox. And then obviously I'm talking here particularly about pCloud, which is a service based in Switzerland, who have a really convenient programmers API for. So when I was trying to work out whether again back at the idea stage, but hadn't quite got to the business case stage, the idea stage was, will this be possible? People want to share their files between multiple devices, including RISC-OS. Will this technically be possible was the question. And I looked at the sort of interfaces that file switch, which is the bit of RISC-OS which deals with file opening and closing and that sort of thing. And I looked at all of these different providers and found that the only one that was really, really closely matched, as in it's almost weird, and maybe they even had a copy of the programmer's reference manuals. It was almost a one-to-one mapping between the pCloud programmer's interface and how file switch works. So it was a really really convenient way to map between those two. It's really thin layer to translate between those two. Behind the scenes, so I should mention that CloudFS is actually a filing system within a filing system. So pCloud is one possible client of that, and as I mentioned, that it was just a convenience that it was so similar to how file switch worked. But in principle, you could write a Dropbox client for it, and I do keep looking at that. There's always some annoyances in their programmer's interface which makes it inconvenient. So I'm at the moment, pCloud has turned out to be a really great partner to have worked with. They answer technical questions and things really promptly when you've got them. So I've been really pleased with that since working with them since 2016. You know, I was trying to remember, as I said at the beginning of the call, when LSR released CloudFS. Apparently it was 2016, and yeah, I think I went to show this to you in when you were at the sports club in 2017, showing you this in person. Now, a few things have happened since 2017, because that is 7 years ago. It's quite a long time. pCloud have introduced an extra set of servers driven mainly by the GDPR privacy rules coming in. So they now give you an option whether you want to store your data in the EU which is Switzerland is in the EU, or certainly in Europe anyway. Or you can store the data in the US on servers in the US. So when you sign up for an account with pCloud, you can choose which of those jurisdictions you would like your data to be in. Obviously, if you put it in the EU, then Elon Musk and friends can't get their sticky fingers, or the FBI can't get their sticky fingers on your data because it's all protected by the GDPR stuff. There's also been some under the bonnet speed ups with improvements to the way that the buffering works, which I occasionally fiddle away with it, and suddenly you get a 300% speed up, and you think, well, that didn't make any sense. Why did that buffering not previously work? And there's some very strange things that go on within file switch and filer action. Yeah, there we are. I'm trying to remember where I put the note about filer action. So filer action has a weird fatal embrace that what it's doing when you're copying files is monitoring how fast you're copying the file. And if it realizes that you're not sending it at what it's got some thresholds internally, knowing how fast it thinks it wants to send it. If it realizes that you're spending more time than it wants sending the data, its strategy is to send it more slowly in smaller pieces, which for a network filing system is the worst possible solution to the problem, because the smaller you make the packets, the more packets you have to send the same amount of data, and therefore everything slows down. So I've got a couple of cunning plans up my sleeve to try and defeat filer action's spiral of doom, where once you get below a certain threshold, it suddenly starts dividing the data up into really small pieces, and that takes forever. And they've also pCloud, because they're based in Switzerland, are super paranoid about everything to do with security, and they have recently added a new feature where you can sign up to, you don't have to, it's optional, but you can sign up to two-factor authentication, so that whenever you log into the account, it will send you a text message via another channel. So it should be possible to get that extra layer of checking done via RISC-OS. The tricky bit there is just working out how to get Omni Client to pause while you're waiting for the text message to arrive. So now I feel the time for a high stakes, almost certainly not going to work first time lucky demonstration. So what I'm going to try and do is take a picture with an Android tablet, which I have just to my left, and send that over to Switzerland, which is 1,055 kilometers as the crow flies, and then pull that back to a RISC PC, which is on a table just to my right here. And then, because there's a RISC PC, I can put an Ethernet NIC in it. You could see where I was going with that, and then mount that using CloudFS and export that as an Ethernet share down the last 2.6 meters of green cable, which is down by my feet, to a BBC Micro, which is on another table just by my knees. So total round trip there is 1,055 kilometers and 2.6 meters. So let's see. Let's just break out of that so that I can. So just go. It's got the tablet here. Just wait for it to power up. And, see who have we got on the screen. So that. So who's on the picture? So Chris, can you just wave your hand or something like that? Thank you. So this is the boring bit for a second, because I need to press the share with my pCloud account. Save to pCloud. Right, I will assume that will do a thing while I talk through the other half of the setup. Right, so over on the next computer down the chain, so we've sent it 1,055 kilometers. The return half, if I share that screen, so this is just me via VNC sharing. This is a RISC PC that's on the table to my right. Nothing too unusual about this, I don't think. I think it's running RISC-OS 3.71. So that's my cloud service. In fact, it's already, the picture of Chris has already arrived. So that's the photo. Is that today's date? 2050, 2035. That sounds right. Yes. That's the date, yeah, the date and time backwards. So I think we can check the midway point. This is a Podule card, 10 base C Podule card, and connected to the Ethernet. So this is coming from Switzerland over here. I'll make that a bit smaller. There we go. Right, there's it's a very flattering picture of Chris waving. So it's made it as far as this computer. So yeah, the other half of the chain here is I've got level 4 Ethernet running, and I've got, just let it enumerate. So this is just enumerating itself. So the local server and the one that I've called cat photos. So cat photos is the one that's in Omni client. That is my pCloud mount, and then that is going to go to BBC Micro. So if I quickly get out of that share and swap to now, whether I'm going to be able to see. Right. Can I see now? I didn't think that through, that now I can't, because I'm sharing that, I can't see. We'll try typing blind. So 46 is the file server's server number. Hopefully that says sys, because I can't see, it's very small. And then the password is secret. Hopefully that logged on. I'm trusting, because it's very small on my screen. Hopefully you can see the share from Switzerland. So it is a live share. It's not being cached locally or anything. It is it's a live share. So if I'm going to dump one of the smaller files, because did I get that? Looks like I typed it in. Yeah, there we go. There's a bit of screen sharing lag depending on which one I look at. Because of course it's going back via Zoom, isn't it? Yes, there's an extra round trip I'd forgotten about. So I did realize that I can't display a JPEG on a BBC Micro, so I'm just dumping the picture of Henry the cat, because that's about 2 kilobytes or something like that, which is not too onerous to do over Ethernet. Hopefully it's near the end, so I'm just reading the very small hex numbers as they go past. Well, I think I'm quietly impressed with myself that I've managed to take a photo, send it to Switzerland, get the photo back, share it via a RISC PC, and then mount that using a BBC Micro over Ethernet. So hooray! Star by the end. And there you go. Hopefully you enjoyed. Hopefully you enjoyed a full round trip there. And yeah, those were the two things that I wanted to cover. If there's any questions that spring to mind, or anything that I can, anything that you want me to hold up in person, I can do.
Have we got any questions? Speak up now.
Comments in the chat.
Can I ask, Rob, when you're
Yeah.
designing hardware for sort of legacy devices like the RISC PC, is that a very different, so you're not trying to like create the world's most cutting edge device because the rest of the hardware will do it. So what's different from a sort of the creating the world's all new whizzy sort of whatever for the latest ARM hardware versus more sort of legacy designs like this?
Yes, you're right in that. Yeah, all the bus speeds on an older computer, either a BBC Micro or a RISC PC A7000, all the bus speeds are sedentary and slow by modern standards. So generally, doing board layouts, you don't have to be too worried about that sort of thing. Whereas, for example, doing the titanium motherboard, where you've got 1 gigahertz RAM interfaces, you need to make sure that you've got do all the trace length matching. I guess the difference with doing something for a legacy design now is, as I was mentioning with the procurement thing, is getting hold of the chips. So a lot of the stuff on older designs runs at 5 volts, and it's very difficult now to get 5 volts only chips. So often you'll find yourself having to do a 5 volt to 3.3 volt level translation, just because you can no longer you can't make an entirely 5 volt design anymore. You have to level translate down. Some of it you can, for example, EPROMs are still being made today, and EPROMs are all 5 volts, but they are, massive silicon technology. The silicon technology you can see with the naked eye. That's how big it is. So yeah, that's probably the main difference is you end up almost certainly doing some kind of level translation or mixed signal messing around. Whereas if you're starting with a blank sheet of paper and designing a motherboard, then you would design everything at 1.8 volts or 3.3 volts, and therefore there's no messing around doing translation. But everything's a lot faster, so it's a lot harder to get through compliance testing, and a lot harder to do the board layout.
This is a comment rather than a question. You mentioned you could choose EU or US storage.
Yeah.
When I was on our parish council, which I've now gave up about nearly 5 years ago now, we weren't allowed to store anything in a US domain. This was a local government restriction, probably to local government at all levels. You couldn't use US domains for storing, US sites for storing your data.
Yeah, even before the GDPR stuff came in, is that like 3 or 4 years ago? Yes, there were already online privacy protections just in local law. So the GDPR stuff and the EU data laws just kind of mashed them all together. There were already things that storing things on US servers where the authorities can go basically just submit a request, and you can go and rummage around in other people's data. So yeah, and obviously that there are ones where you knowingly sign up to a service, and that service will index your data and use it for things that you didn't necessarily want them to. So I'm not sure. I don't use Gmail, but Google is fundamentally a search and advertising company. So yes, they might be offering you an email service for free, but the trade-off for that is that they may also be using your emails for to send you more targeted advertising and things like that. So yeah, there's definitely quite a steep difference, and I suspect in the next 4 years might get even more steep between what happens in the US in data privacy terms. Yeah.
Well, there's one or two comments on the chat. Have you seen them?
Yeah, just scrolling back through that. So how to get yeah, I can see we've got icon bar and risk oscillatory locking horns. Where does Ethernet fall in this diagram? I'm not sure which diagram I was showing at the time. So yeah, web service to convert a JPEG to a Mode0 sprite. Yes, that's very true. Yeah, I did. Yeah, when I was trying to come up with what demonstrator I could do, it was I was struggling to think what I could input at one end that was visually interesting. So yes, had I done something where it was just a text file, or got someone to give me a phrase or a joke or something, I could have typed that in on a tablet and saved it as a text file, and then I would have been able to look at that natively on a BBC Micro. I don't think I ever did anything with JPEGs on a BBC Micro. I remember making a sprite to Mode0 converter, but yeah, not the decompressing JPEGs would be a bit of a challenge, I think, in 32K of RAM. What do you reckon the market is for Ethernet NICs? Quite small, yes. There was, in some ways, the Ethernet NIC, as I was saying, yeah, it's a niche within a niche, and a lot of that was just a long-term wanting to scratch an itch. So yeah, I would have thought probably it's in the tens. It's definitely less than 100. So tens is the right kind of number to be thinking of. And that was part of the motivation behind doing the 100 base T, which I didn't focus on today, but yeah, there's also a 100 base T, a normal Ethernet for slightly more useful networking. And that was very much born out of, well, I've paid for the tool to bend the piece of metal, I might as well get them to laser a square in it instead of an oval. And so, yeah, that was essentially the business. The idea for that was very simple, and the business case was, well, you've already paid for the tooling to make the metal plate. You might as well make a metal plate with a square hole in it instead. So I'm very much expecting the Ethernet NIC to be, yeah, I don't know, at least a factor of 10 more useful than an Ethernet NIC in terms of there can't be that many live Ethernets left in the world now. I guess I might be like a quarter of the world's Ethernets here. Yeah. Then yes, question from Bernard: how do I upgrade CloudFS? Yes, so if you want to upgrade your CloudFS, just rerun the install and it will download the latest version from the LSR server. Yeah, Vince has already answered that. Thank you very much.
Oh, okay, thank you, Rob.
Yeah. Doug, what about upgrading from an Epic version to the latest? Yes, so the Epic version is frozen in time. Yes, if you desperately need that and haven't bought an Epic recently, I could email that. Essentially, I hand it's an offline installer for the one that goes onto the Epic distribution that RISC-OS Open sells. And I just hand that over, and that runs until whenever it is that Epic next gets updated. I should add the change between since Bernard is mentioning it, and I guess indirectly Doug is asking the same question. Between version 0.34 and 0.35 was a microscopic change, as I suppose the 0.01 change in the version number reflects. What that was if you called the file switch API to query what the directory contents are, if you only ever asked for one, what it would actually do would be to fill the buffer that you gave it with more than one. So it was ignoring the fact that you had only asked for one item by return. And no one has ever noticed that for the last 7 years until Swift JPEG came along. And it turns out that, yeah, Swift JPEG viewer does do that file switch call where it gives you a really massive buffer. It's like a 1 kilobyte buffer, and then it says, please could I have just one file name? And yeah, CloudFS was not respecting that one in that situation. So it was a very, very small update.
Yeah, question, Rob. Is there a limit to how much you can store on pCloud?
There's a free limit. So if you sign up for their free account, you can get up to 10 gigabytes of storage. So you get, I think you get 2 the very second you sign up. And then if you accept a text message from them, you get another gigabyte. And if you tell your next door neighbor about pCloud, you get another gigabyte. And eventually you end up getting 10 gig of free storage. Anything above 10 gig, you have to pay for. So it's of the order of something like £50 a year. I'm going slightly from memory there, and that will give you terabytes kind of levels. So again, the storage is super cheap, and I guess that's why they give you 10 gigabytes for free. Thank you. Vince has looked it up for me. £4.49 a month. So yeah, my bad maths. So that's £60 a year, isn't it? Roughly. And then yeah, that gives you basically terabytes worth of storage, so you can back up your PC and back up your mobile phone and back up everything as well.
Do that because now I've got faster broadband, I can do it.
Yeah, I find it very useful. I used to end up putting memory sticks in my pocket or in my rucksack and taking things around with me, and then I'd lose the memory stick. So it's really handy. Just before I set off somewhere on my bike, I copy files onto CloudFS, get on my bike, go to the other end, and then just log in using somebody's web browser at the other end on their free Wi-Fi and retrieve the file that way. Like if I also go to my mum's house or something, if I forget my laptop, it doesn't really matter. I can just log in on her computer and get whatever it was that I was sending to myself. Very handy. So, what encryption does it use? I don't remember what the encryption pCloud uses, but they're very proud that they've got something like a £10,000 bounty or $10,000 bounty that if you can hack their server, they'll give you $10,000. So they're very proud by their levels of security. You can pay for an extra level of encryption where it will also scramble your local copy. That is not supported in the RISC-OS version, so you can't do local scrambling of the data on RISC-OS. But if you've got the PC version, yeah, they do an extension where it will scramble your hard. So if someone stole your computer and crack the top off it, they would not be able to get your files would be useless to them. They'd just be a load of gobbledygook. But that's not supported by the RISC-OS client, because they won't tell you what the encryption. Yeah, it must be whatever it is. It must be secure enough that they don't give you the source code for it.
Somebody's revealing the secret.
yeah, it's definitely not ROCC 13, and it's not exclusive ORing it with a developer's initials either, which is the other usual strategy for security. Exclusive OR it with your own name.